Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center with today's topic, three-dimensional shapes. Now what is the third dimension? We've been working in and with two dimensions with flat shapes, especially with our graphs that we did, because I have a graph here because when we work with graphs and do graphs, we have the x-axis and the y-axis. When we add our shape to it, we draw out a graph or a shape on our graph, and it gives us a flat two-dimensional image. Now, in order for something to have a third dimension, you need a third axis. So that would mean we have our x, our y, and our z axis. Now, when you have a three-dimensional shape, it has height or depth to it. Just like us, our bodies have depth and they pop out. They're in the third dimension. So when you have something like the z-axis, you have your x and your y, and your z-axis pops out at you. So if we lay it down like this, like a two-dimensional shape with your x and y, your z would pop up from the page, popping up, giving it height or depth to the shape. So let me show you an example of a two-dimensional shape to a three-dimensional shape. Our first two-dimensional shape example would be a circle. From a review, the circle has no sides, no corners or vertices, or no angles. It is a flat circular shape. My example that I have is a coaster. So I have this coaster here that represents the circular shape in a two-dimensional object. Now, adding that two-dimensional object to the graph, you have it appear in two dimensions, flat along the x and the y axis. Now, it being flat on the x and y, I need to add a third dimension to it. There's the z. So what do I need to do to make it in its third dimension? I need to grab and pull up on the two-dimensional shape on the graph. So let me grab and pull. I pull up, and what appears is a three-dimensional shape we call a cylinder. So we started with the two-dimensional shape, the circle. I pulled upward, which gave it height or depth along the z-axis, and now we have a roll of toilet paper, which represents our cylinder. Now, other shapes you can do the same thing from its two-dimensional shape to its three-dimensional shape. The cylinder happens to be our first example of the three-dimensional shape, where you have with the toilet paper, you have three faces. Just like us, we have a face, which would be like your side on a flat two-dimensional object. So you have three faces, the round circle on the top, the round circle on the bottom, and then the wrap around sort of body of the cylinder is your third. Your edges would be along the top, 1 and 2 along the bottom, and there are no corners or vertices on a cylinder, because notice it's rounded and smooth all the way around. And examples of a cylinder, also called a tube, would be things like soup cans, barrels, toilet paper tubes, and rocket bodies, the body, the tube shape of the main rocket. The next two-dimensional shape to three-dimensional shape still involves our two-dimensional circle. But instead of just giving one height lift up, it lifts and does top and base. And we call that a sphere. A sphere, like I'm holding in my hand, the spherical ball. And a sphere has only one face, one continuous curved face that goes all the way around and very smooth, no edges or corners, which are vertices, so it's nice and smooth all the way around. common spheres that we see around us every day happen to be also called globes, balls, planets, and even the stars that we have in the sky, our own sun, all happen to be spheres. Gravity likes to put things into spheres out into the cosmos, so a sphere is a very common shape in the universe. Now, for example, putting that on our two-dimensional graph, again, we have our flat circle, and to add some depth or height to it, I have a balloon as an example. So notice it's a flat, circular shape, and you just give, and you have that smooth, one face, no edges or no curves, but 3 dimensions. Our next most common two-dimensional shape to three-dimensional shape happens to be the square, which has its 4 sides, 4 vertices or corners, and the 4 angles. Very common shape to find. Our homes, things that we work with, our binders, paper, are all made in this square shape. Now, if you set a square onto our flat X and Y, to give it height or depth, we again pull up to give our Z-axis, and I have that example here. I have a square, and to give it depth, I need to give it some height pulling up, and you form a cube. So when you pull up, you give depth and dimension. Notice it looks like my head is far away because you have the different multiple sides and depth to this three-dimensional shape here in front of me. Now, the cool thing about a cube, we call them cube, but there are other names for it. You can call it a hexahedron. Hexahedron meaning hex is a term for 6. 6 hex for hedrons, 6-sided or 6-faced. Because when you have a cube and you pull up, you have the 6 faces on its various flat surfaces to make it a 6-sided shape, or cube, or hexahedron. You have 12 edges along your faces, and then you have 8 corners or vertices as well, making it a very common and very fun shape that we can play games with our dice, having boxes and packages delivered to us, and ice cubes for our iced tea in the summertime. Now, on to my favorite shape. We have the triangle, the two-dimensional shape with 3 sides, 3 corners or vertices, and 3 angles. You have a triangle, and when you have a triangle and you pull upward on the triangle on our two-dimensional graph, adding that 3 dimensions with the Z, you get a pyramid with the Z there popping up for height and depth. So you get a pyramid. So this is one type of pyramid. It's not like the pyramids that you find in Egypt, because that is a square base pyramid, whereas this is a triangular based pyramid we call a tetrahedron. A tetrahedron has 4 faces, and it has 6 edges, and it has 4 vertices or corners. And tetrahedrons are very common if you play D&D like I do. It's one of the dice shapes, that you roll, and it happens to be something like an example with a tent, that you could pitch a tent and go camping in. But this is one of the cool shapes that comes from a triangle. Now that we've gone over our two-dimensional to three-dimensional shapes, I encourage you to go throughout your house and discover different three-dimensional shapes like the objects that we did today and reviewed today, like the sphere, like the triangular pyramid or tetrahedron, the hexahedron or cube, or even our cylinder that we have, I encourage you to go and be your own investigative geometry, searching out in your house and finding different three-dimensional shapes and objects that are useful in your house, that you use every day, and maybe never thought about that's that shape or that's that shape for a reason, and it has its length and its width and its height or depth, and the X, the Y, and the coming right at you Z axis. Just like the world is filled with three dimensions and ever changing, note that science never stops.